Section 2.6 is about inverse of a square matrix. The matrix is a square matrix if number of rows is equal to number of columns. For example, 2 by 2 matrix is a square matrix because it has 2 columns and 2 rows and they are equal. I mean, number of rows is equal to number of columns. Now, how to find the inverse of these matrices and what is the importance of finding inverses? Let's start with the first question. What is the inverse of a given matrix or of a square matrix? Let's start with the 2 by 2 matrices. If A is 2 by 2 matrix, consists of A, B, C, D, those as entries, this matrix is invertible. Invertible, that means the inverse does exist, and we use this notation to denote the inverse. This is read inverse matrix of A, or inverse of the matrix A. Inverse of the matrix A. So this is not -1. This is just notation that indicates we have inverse of a matrix. Now, how to find the inverse of 2 by 2 matrices? In this case, we apply this formula. So the inverse A inverse is 1 over AD minus BC. What is AD minus BC? We multiply this way, the diagonal, AD minus B times C this way, this way, then this way, and we put that in the denominator here. So this is AD minus BC. And then inside the matrix, we change the positions of the elements on the main diagonal, as you can see here. We interchange A with D. As you can see here, D becomes here and A is here. Now, and on the other diagonal, this one, we change the sign. We change the signs, just the signs. As you can see here, we have BC, it becomes negative B and negative C. So this is how we find inverse of a 2 by 2 matrix. For example, here we have a 2 by 2 matrix. We want to find the inverse. So we multiply this by this, the main diagonal. So A inverse is 1 over 5 times 1 minus, we multiply 2 by 2, the other diagonal. So 2 by 2. And then the matrix, for the matrix, we interchange elements on the main diagonal. This is the main diagonal. We interchange elements. 1 becomes here and 5 becomes here. And on the other diagonal, we change the sign. So this becomes -2 and this is -2. Now we simplify. So we have 5 minus 4, which is 1. So 1 over 1 is 1. So we are left with the matrix 1, -2, -2, and 5. So this is A inverse. So the inverse of the matrix A equals 5, 2, 2, 1 is the matrix 1, -2, -2, 5. So this is how we find inverse of 2 by 2 matrices. But actually this is a special case. This is true for 2 by 2 matrices. But what about 3 by 3 matrices? And other matrices, 4 by 4 matrices, and higher sizes matrices. So what should we do in this case? We need to learn a general method that can solve any problem and finding inverses. So matrices with any size can be, any square size, 2 by 2, 3 by 3, 4 by 4, etc. We can find the inverse for these matrices using the general method. The general method says you extend the given matrix. If we have A, B, C, D, so we put the matrix here and then we add the identity of that matrix. The identity is the matrix that has ones on the main diagonal and everything else is 0. For example, if we have 3 by 3 matrix, for example 3 1 1 0 2 5 2 1, then we need to add identity, 3 by 3 identity. This is the identity matrix. As you can see, same size, 3 by 3 as the original matrix, and the ones are on the main diagonal. This is the main diagonal, and anything else is 0. And as you can see here, the notation I used, this notation for the matrix, is the same as the brackets. So some people prefer to use this for matrices and put the numbers here. Some people use brackets, so don't worry about the notation. I mean, in the context of our textbook. So we extend the matrix by adding the identity. So this is the matrix A and this is the identity. Then we apply simple or elementary row operations to convert the left side, I mean the matrix A, we convert it into identity, and then the identity will be changed according to that change, because that change, the simple row operations, will be applied on the whole line. I mean, for example, if we applied for one element in the first row, it will be applied for all numbers in that row. Similarly, if we apply them on the second row, that means our element on the second row, then we need to apply it for all elements. So after applying elementary row operations, the matrix I will be changed to the matrix, a new matrix that's called A inverse. So we put the matrix A and we put the identity in, adjacent to it or next to it, and then we apply elementary row operations as we did in the previous video or previous section, 2.5, to convert the matrix A into identity, and then the resulting matrix on the right will be the inverse. Okay, now let's do example 1. The above example. So we have the matrix, and here, as you can see, I just applied a rule. This is rule. You can apply it, or you can use the general method that I'm gonna explain here. We should get same answer. So the matrix A and its identity can be written this way. The matrix A is 5 2 2 1, and then we put the identity. The identity is 1 0 0 1, and then since this is A, this is the identity, we need to convert A into the identity. Now, how to do that? We can apply different ideas here, or different methods to make the first element 1. So we want to change the first element into a pivot that's equal to 1. Now, how to do that? Actually, we can multiply the second row. If we multiply the second row by, for example, negative 2, and add that to the first row, what happens to the matrix? If you multiply the second row by negative 2, negative 2 times 2 is negative 4, and add it to the first row, negative 4 plus 5 is 1. And then multiply the next element, negative 2 times 1, negative 2, and then add it to the above, the corresponding element from the first row. That will give us 0. And then multiply negative 2 by 0, that gives 0. We still have 1 here. Then we multiply negative 2 by 1, that's negative 2, and then we add it to 0, so we put negative 2. Now we have the first element is the 1, and that's the pivot, so we are on the right track. So we need to make every element else in that column equal to 0. So we have 2 here, so we need to make this make this 0. So that can be happen by multiplying the first row by negative 2 and add it to row 2, and then that would replace row 2. Now that will change the matrix as follows. So multiply the first row by negative 2. Negative 2 times 1 plus row 2, that gives 0 because we have 2 on the second row. Okay, so I'm gonna add to this row. Now we multiply -2 by 0 and add it to the number here, to 1, and that will be stay 1. Then -2 times 1, -2, and then we add it to 0, so that's -2. Then we multiply it by -2. -2 times -2, that's 4, and we add it to 1, that gives 5. Good. Now, as you can see on the left hand side, we don't need to proceed more because we already got an identity matrix. So the identity becomes the first matrix, and the resulting one on the right hand side is the inverse. So A inverse is 1, -2, -2, 5. So if you compare this with what we got here, you find that we got the same answer. Now let's back to the first issue of this problem and how to convert the first element into 1. I mean, this element, we want to make it 1. I said one of the methods is to multiply the second row, because we can multiply any row by any number other than 0 and add it to the other row. So I think about this, how to make 5 to convert 5 into 1. So we need to subtract 4. How to get those 4? We multiply the second row by -2, we get -4, and add it to the first row. That will give me 1. Or if you don't want to go through this process, you don't want to multiply by some element, you can do it this way. You can multiply the first row by 1/5. 1/5, 5, 2, 2, 1, 1, 0, 0, 1. So when we multiply by 1/5, this becomes 1, and this becomes 2/5, and this becomes 1/5, and this stays 0. And then the next step is to make this equal this 0. How to make this 0? We multiply by -2. -2 times row 1, and then add it to row 2. This will make this number 0, and so on. But as you can see here, we have to deal with fractions, like 2/5. So, and some people don't prefer to deal with fractions because you need to get common denominators when you add or subtract. But you can apply this method as well. So whatever you decide, either to multiply that number, that value, that entry you want to the one you want to make it 1 by reciprocal of it, or you can multiply another row by some number and add it to that value to make it 1. So it's up to you. Good. So this is the general method. This is the general method, and this can be applied for all matrices of higher dimensions. I mean square matrices of higher dimensions, like 3 by 3, 4 by 4, etc. But this here, the first example, was a special case. It can be applied only for 2 by 2 matrices. And for me, I recommend you to use the first method rather than the second method for 2 by 2 matrices, because that's much easier. Now let's find the inverse of this given matrix if that's possible. Now let's see. We want to find A inverse. I don't want to use the general method here. I'm going to use the rule. So I multiply 8 by 3, and that's 24. And then 4 by 6, that's 24. And then I need to interchange elements on the main diagonal. So this is 3, 8. And I'm going to change the signs of the elements on the other diagonal. Now simplify, you get 1 over 0 times this matrix, but 1 over 0 is not possible, impossible. Why? Because we can't have 0 in the denominator. So this is not invertible, We can't find the inverse of this type of matrices. Okay, good. Now how to find inverse of 3 by 3 matrix? We don't have a rule, but we need to use the general method. So how to use the general method? We have 2, -3, -7, 0, 0, -1, 1, -2, 1, or I may make some changes on numbers so that we can use the example here next. Okay, so let me see. We may use same elements as here. Yeah, I'm gonna make some changes on this example so that we can use the same example and invest our time. So I'm gonna change this into the matrix 3, -5, -2, then 0, 0, -1, 1, -2, 1. So I'm just changing the first row. So this is 3, -5, and -2, just to use the same example in the next when we discuss other concept, how to solve system. Okay, so this is the matrix under consideration, and we want to find the inverse. So in order to find the inverse, we put A and its identity here in a new extended matrix. So the matrix A is 3, -5, -2, 0, 0, -1, 1, -2, and 1. And then we add here, extend it by including the identity, the 3 by 3 identity matrix. Okay, now we need to make this is A, this is identity. We need to make the identity, the matrix A identity. How can we do that? We need to get the first element equals A, 1. I mean, we need to get this matrix here. How to do that? We need to make the first element 1. This is the first step to get a pivot. But how can we do this? In order to do this, we already have 1 here in the third column, third row. So we can interchange those two. So let's interchange row 1 with row 3. So we get the matrix 1, -2, 1, 0, 0, 1. So we take the whole row. And then we have 0, 0, -1, 0, 1, 0, and then the first row becomes the third row. Now the next step, so we have a pivot element here, it's the number 1, and then we need every element in that column equal to 0. But as you can see here we have 0, 0, -1. It's very similar to the third row of the identity matrix. So let's interchange the last 2 rows to make computations easier. So if we interchange row 2 with row 3, we get the matrix. In the second row we have 3, -5, -2, 1, 0, 0, and then the second row becomes the third row. Good. Now we have this matrix. We want to make this element here 0. How to do that? We multiply the first row by -3 and add it to row 2, and that will replace row 2. So let's see what will happen here. So the first row is 1, -2, 1, 0, 0, 1, and now we multiply the first row by -3. This can be done you do that in mind, mentally, and then add it to row 2. So multiply 1 by -3 and then add it to 3, that gives 0. Multiply -2 by -3, that's 6, and add it to the next row, that gives 1, because 6 minus 5 is 1. Now -3 times 1, -3, and add it to -2, that's -5. And then multiply by 0 and add it to the next row. You still have 1 because you multiplied by 0. Here you multiplied by 0, and then you multiply by 1, so -3, and add it to the next row. You still have you get -3. Good. Now we have 0 here, and then the third row is 0, 0, -1, 0, 1, 0. Good. So we got one pivot element, and everything else in that column is 0, and that's what we call the unit column. So we got unit column, first unit column here. And then we look at the next pivot. The next pivot will be here, and as you can see, this is already 1, so we are fine. We make the number below that, the entry below that, 0, but this is already 0. Good. So next we make the element above that 0. How to do that? We need to multiply the second row by positive 2 and add that to row 1, and then that will replace row 1. So let's see what we get here. So the third row is the same, and the second row will not be changed. And then we multiply second row by 2. So I'm gonna use another color. 2 times row 2, 2 times 0 is 0, and then add it to row 1. Plus 1 is 1, and then 2 times 1 is 2, and add it to negative 2, that's 0. 2 times negative 5, negative 10, plus 1, negative 9. Then 2 times 1, 2, plus 0, 2. 2 times 0 plus 0 is 0. 2 times negative 3, negative 6, plus 1, negative 5. Good. Now we have the second row became unit column. So we have 2 unit columns. Now we look for look at the third column. We want to make it a unit column. That means we need this element here to be 1 and everything else in that column equal to 0. So the first step is to convert that number into positive 1. We don't want negative 1, we want a positive 1. So let's do the operation here. I'm going to multiply row 3 by negative. So negative times row 3, put that in row 3. So just multiply row 3 by negative 1. You need to change the sign of this and the sign of this. So this matrix becomes, this row becomes 0, 0, 1, 0, negative 1, and 0. Good. Now we need to make those two elements or entries negative 5, negative 9, zeros. How to do that? We multiply the pivot, the row of that contains the pivot 1 by the inverse of those numbers, or I mean the opposite, I mean these numbers with opposite sign, and then add it to these numbers. So let's start with negative 5. We want to make this 0. So we multiply row 3 by 5 and add it to row 2. So row 3 is 0, 0, 1, 0, negative 1, and 0. We multiply it by 5 and add it to row 2. So we still have 1 because we multiply 0 by 5. That will not change row 2. And then same thing here, we get 1. Then here we multiply by 5 and add it to row 2. We add it to negative 5, that's 0. And then we multiply it by 0. That will not change the corresponding entry in row 2. We multiply this by 5, negative 5 plus 0 is negative 5, and then we multiply this by 0 by 5. That will not change the corresponding entry. And in the first row we have 1, 0, negative 9, we have 2, 0, negative 5. Good. Now we've got 1 and 0 here. We need to make this 0 as well. How to do that? We just multiply row 3 by 9, positive 9, and add it to row 1, and that will replace row 1. That should be the last step. So we have 0, 0, 1 in the last row, and we have 1, 1, 0. Actually, this is not 1, 1, 0. That's 0. I should try 0 here. This is 0. Yeah, this is typo, sorry. So 0, 1, 0, and 1, negative 5, negative 3. Now we want to multiply row 3 by 9 and add it to the first row. In the first row we have 1. Since we are multiplying 0, we still have 1. We multiply 0, we still have 0. Now we multiply this by 9 and add it to the first row, we get 0. 9 minus 9 is 0. Then we multiply this by 9. That will not change the corresponding element in the first row, and then we multiply this by 9, we get negative 9, plus the corresponding element 0 is negative 9. Then we multiply this by 9 and add it to the corresponding element, it's negative 5. And that's it. Now, as you can see here, we have identity to the left. Instead of having the identity to the right, it becomes to the left, and the resulting matrix on the right is A inverse. So A inverse is the matrix 2, negative 9, negative 5, and 1, negative 5, negative 3, 0, negative 1, and 0. Okay, so this is how we find the inverse of 3 by 3 matrix. And as you know, if for higher dimensions, the computations will be harder because we need to do more steps. Okay, now that's the idea, how to find the inverse of 2 by 2 matrices and inverse of 3 by 3 matrices. For 3 by 3 matrices, we don't have another choice. We need to apply this method. For 2 by 2 matrices, we can use either the rule or this method. Now let's move to the next thing that we want to discuss in this video, the matrix equation. And here we want to apply what we learned about the inverse matrix in solving systems. We learned before how to use elimination, substitution methods, and Gauss-Jordan elimination. Now there is a very powerful method that's called inverse matrix method to solve these systems. So here we have a system, we are given a system of 2 equations, and we want to solve that system. But first we want to write matrix equation. What do we mean by matrix equation? Matrix equation is an equation that's written using matrices. Can be written this way: AX equals B, where A is the coefficient matrix, and X is the variables, and that's just one column, and B is the constant matrix. So here we have, what are the coefficients? 2, 3, 3, 5. Those are coefficients of X, those are coefficients of Y. And then what are the variables? We have 2 variables, X and Y. On the right hand side we have constants, 14, 23. And that's it. This is now written using or in a matrix form, or as a matrix equation that involves matrices. Now the second thing we're asked to do is to solve the system using the inverse of the coefficient matrix. What is the coefficient matrix? This is the coefficient matrix. We want to find the inverse of this matrix. So how to solve the system using this? We solve the system by finding the A inverse, and then the solution X is A inverse, the inverse matrix that we obtain, we multiply it by the constants. And that will give me the solution. That's solving system using the inverse of the coefficient matrix. So the first step is to find A inverse. So what is A? The matrix A is 2, 3, 3, 5. Then we find the inverse of this matrix. Let's apply the rule. We need to multiply this way. 2 times 5 is 10, minus this way. 3 times 3 is 9. And then we interchange elements on the main diagonal. So we have 5 and 2, and change signs of elements on the other diagonal. So negative 3, negative 3. As you can see, 10 minus 9 is 1, so that will not affect the matrix if we multiply it by 1. So the inverse is 5, negative 3, negative 3, and 2. So this is A inverse. Good. And then we need to multiply it by B. B is 14 and 23, the constants, the elements or the numbers on the right. So A inverse times B is the matrix 5, negative 3, negative 3, 2. We multiply it by the constants, 14 and 23. Okay. Now we multiply these matrices, and how to multiply two matrices. We need to check if number of columns of the first matrix is equal to number of rows of the second matrix, and that's satisfied. That means we can multiply, and the resulting matrix is 2 by 1 matrix. Now here we have matrix that consists of 2 rows and 1 column. So how to multiply? We multiply the first row by the column. So 5 times 14, this is 70. Now negative 3 times the corresponding number is 23. That's negative 69. And on the second, we multiply the second row by that column. We distribute it. So negative 3 times the corresponding elements 4, that's negative 42. And then we multiply 2 by 23, so that's 46. Now we add these, we get 1 and 2. Now is this a solution? Yes, because if you, this is x and this is y. Let's check. If we plug x here and y here, we should get 14. So let's see. X is 1, 2 times 1 is 2, plus 3 times 2 is, okay, so let's double check here. We have, this is 4, sorry. This is 4. Negative 42 plus 46 is 4. Now, 3 times 4 is 12, so the answer is 14. That's the right-hand side. So let's apply it on the second equation. 3 times 1 plus 5 times y, which is 4. Now 3 plus 20 is 23, so our solution is correct. So the answer is, the solution is the matrix XY. This is called capital X matrix. It includes the integers x and y is equal to 1 and 4. So this is x and this is y. This is how we solve the system. So now we got a new method to solve linear systems. It's called the inverse coefficient matrix method. Now let's do 3 by 3 systems. Here we want to write the equation, these equations, in the equivalent system use or matrix form or matrix equation. So we put the constants first. The constants are 3, negative 5, negative 2. And in the second row, we don't have x, we don't have y, we have negative z, so the coefficient is negative 1. And the third row, 1, negative 2, and 1. So this is the matrix A. And then the matrix X, the matrix of variables. What are the variables? They are x, y, and z, equals the constants. That's the matrix B. The constants are 4, 3, and negative 8. That's it. This is written in the as a matrix equation. Now we want to solve this system using the inverse of the coefficient matrix. That means we want to find A inverse and then multiply it by B. But we already did that in this example. Because this is the same as A below. So here we have A. This is A. What is the inverse from above example? A inverse is here. 2, negative 9, negative 5. 1, negative 5, negative 3. And 0, negative 1, 0. So this is the inverse matrix. Then we multiply it by B, and that will give us the matrix of variables x. So we multiply this matrix by the matrix B, the constants. The constant matrix of constants is 4, 3, and negative 8. Now we multiply as usual. This is matrix 3 by 3 matrix. This is 3 by 1. So we can multiply since the inner values are numbers are the same. The resulting matrix is 3 rows by 1 column. So 3 rows by 1 column. We multiply the first row by the column. So we distribute, we multiply each element with the corresponding element. 2 times 4 is 8 plus negative 9 times 3, negative 27, plus negative 5 times negative 8, that's 40. And then the second row, I'm going to use different color, the second row by this column. So we multiply 1 by 4, which is 4, plus negative 5 by 3, negative 15, plus negative 3 times negative 8, 24. And then the last row, we multiply the row 0, negative 1, 0 by this column. So we multiply the corresponding elements. So 0 times 4 is 0, plus negative 1 times 3 is negative 3. 0 times negative 8 is 0. Now we simplify. So this gives us 21. And the second entry, 4 minus 15 plus or minus is minus. Minus 15 plus 24 is 13. And the last row is 0 plus negative 3 plus 0 is negative 3. So this is the matrix X, which consists of the variables X, Y, and Z. So the value of X is 21, the value of Y is 13, and the value of Z is negative 3. If we want to check our answer, we can plug here into the original system. Let's do it for some value. So for example, you can check, but let me see. Here negative Z equals 3. Z is 3, so we can just plug it there. Z is negative 3. We just plug it here. Negative Z, negative 3 is positive 3. So we got this, and you can check the other equations.